Hi, everyone, and welcome to DeepStation AI, where we bring together AI engineers, professionals, and enthusiasts so we can all stay ahead of the AI wave. Today, we have Leandro Lima, a machine learning engineer at Block, well known for Square and Cash App, after spending 2 years as a machine learning engineer at Meta. We're excited to introduce the topic of the series, Introduction to Machine Learning for Beginners. And Leandro, how about you introduce yourself?
Hey, Grant, it's nice to be here. My name is Leandro. As you said, I'm a machine learning engineer. Um, I'm working at Block right now, the parent company of Cash App and Square, also Tidal, Afterpay. I spent some time at Meta uh, as a machine learning engineer as well, working with video recommendations and also working with integrity. Yeah, and before that, I used to work with in a field called bioinformatics, where I
Hmm.
was using machine learning to predict or to understand which patients would develop specific disease based on their genome data. So basically, analyzing DNA, RNA to understand how people develop some diseases. Well, and we're here to have fun, um, learn a bit of machine learning, discuss some fundamentals. I believe we're in a time where people are really interested about AI and machine learning, and I think sometimes we know what we want to do, but we don't know exactly how things work. Um, for example, how come you go to YouTube and YouTube knows exactly what you want to watch, or maybe Netflix, or maybe sometimes you're, you know, on Instagram or Facebook and the right ad is recommended to you. How do they do that? So it's not magic. It's something called machine learning. Um, Also, you know, how people predict um, if a person, will be a good payer, or if a specific user will click an ad on the internet. Everything is done with machine learning. And we're here to discuss, the very basic um, concepts that drive all these decisions. What exactly is going on? Um, and yeah, that's it. We're gonna start discussing how all these things work.
I mean, that's absolutely amazing. And no one better to learn from than you with so much experience over at Block and also with your previous experience at Meta as well. I mean, we're very excited to learn from you. Also, just for context, Leandro's been part of our community now for over a year now, been following DeepStation for a long time. And so really excited to get started. So
Yeah,
should
me
I
too. Me
share the
too.
screen?
Yeah, let's do it.
All right, let's do it.
Cool, cool. Yeah, so um, to start with machine learning, we need to think about numbers. You know, um, so a table will be usually something like this, right? It's something we open in Excel or Google Spreadsheets or LibreOffice. Um, we have usually columns that represent what we call features, right? And the rows represent some instances. Um, what could that be? For example, customers, and we have some data about, um, let's say, if they have a specific loan, um, their age, their gender, all those things will be the features. So we put that in the different columns, and each um, customer would be in each row, right? So here we can't see anything like, customers, or, age, gender, nothing. It's just numbers, right? So I put this here, and this is still not the iris data set as it says in the title. The iris data set is in the first tab, but we're not gonna go there right now. So we're here just to try to understand patterns in numbers, right? So basically, machine learning is, let's say, the power that we have to predict data based on, like we want to predict unknown data based on some known data, right? So here we have three columns, X, Y, and Z, and they have a relationship, right? So imagine instead of X, Y, and Z, we could have like height, weight, um, age, gender, or like things like salary, number of kids. All these are, things that measure something about a specific data point, right? The data point could be a person, could be a product, could be a video on YouTube, and the features is are like what we measure about these things. So, for example, what do we measure about um, YouTube videos? So we have number of views, number of likes, for example, when it was posted, um, who posted it, like how many followers the person who posted has, things like that, right? So all these things will help us to predict things um, about what we want to predict. But let's think about these numbers. And um, so when we think about machine learning, we have to think of predicting something, right? So imagine I hide this column, and I want to predict it based on X or based on Y, right? So let's say we want to predict column Z, right? Do you see any relationship between column Y and column Z? Just looking at the numbers?
Yeah, they appear to be very similar in that V is just a plus one of Y.
Exactly. And you're absolutely right. It's
Yes.
just, yeah, it's just, yeah. So basically, when we do machine learning, we are comparing numbers and we are trying to find this formula, right?
Right.
Sometimes, so here it's exactly one plus one, right? So
Hmm.
Z in this case is Y plus one.
Hmm.
Um, and yeah, Z uh, Y plus one. I think it will regenerate the numbers sometimes because I asked these numbers to be generated randomly. So for some reason, when I update the rows here, the numbers are all regenerated, but the relationship doesn't change. So
Yeah.
this one is actually this one plus one, right?
And I think a lot of people will find it interesting how a feature is just some people are intimidated when they learn about machine learning, right? And to learn
Uh-huh.
that, and they're afraid of, what is a feature, right? And now you're explaining it so easily that, a feature is essentially a data point, something that you're wanting to measure.
Exactly, exactly. Right. Do you see any relationship between X and Y? That's
Hmm.
a little
Yes,
harder.
little trickier, little
Yeah.
trickier. Yeah. How? Yeah, I would love to learn more.
Yeah. So, for example, this one, oh, I just gave the
It's a
script
times three in this case, right?
times three. Yeah, but
Right.
all
Yeah.
of them are
Perfect.
right. Okay. So if we found the relationship between X and Y, right? So this case, Y would be X times three, right?
Mm, right.
What would be the relationship between Z and X? So Z would be exactly, well, what's Y? So Y is X times 3. Then Z would be X times 3 plus 1, right?
Yes.
Well, sometimes the numbers are not as perfect, right?
Right.
For example, this one is even better to understand, right? It's the same relationship, just y is 3 times x, right? And then z is 3 times x plus 1, pretty much the same thing, but with, you know, smaller and integer numbers. Okay, so when we think about machine learning, um, we always have a function uh, that we will call, for example, f of x, right? Where usually x is an entire table, and machine learning is basically that, is trying to find the pattern in x that will predict a variable called, usually it's called y. Um, so we would have something like this: y equals f of x, right? In this case, for example, f of x is 3 times x, right? If we're trying to predict the z variable, that would be x times 3 plus 1. But anyways, as I said, usually it's not as perfect as in this case, because this was created by me, and I,
Hmm.
it's not real data. It's just
Right.
fake data, and I created the exact formula. Sometimes the difference will be, a slightly different. For example, we could have plus zero point 0.1 here. Here we could have uh, uh, plus zero point 0.2 or minus zero point 0.3. It's still very close, but the numbers are not always the same, right?
Right. Pattern becomes harder to detect.
Exactly, exactly. But there's a way to find, you know, um, the function that will be kind of in the middle, um, and that will be a good prediction for the function of x, right? And this method is called, and it's also known as a machine learning algorithm, linear regression, right?
Mm.
So now I want to show a website that we've been developing, and we've shared with the DeepStation community already, called
Beautiful.
Interactive
And
ML.
yeah, beautiful website.
Nice, nice. Thank you. And it has, a lot of concepts about machine learning. It's still being developed, um, but we're gonna take a look at linear regression right now, just to understand what are the steps we need to take to create something with machine learning, right? So first of all, we need the data, right? And we're gonna talk about the iris data set um, really soon. Um, and I'm going to explain what the iris data set is. Um, but first, let's go back here. So we have the data, right? And we want to predict something that's missing in the data, right? Um, so, for example, we want to predict if a person will click an ad, right? So, given some type of information, we want to predict that. Or we want to predict the price of a house, like Zillow does. Um, we have, for example, data available that's number of rooms, the square footage, um, you know, number of bathrooms. We have the zip code. Um, we have, I don't know, if there is a
Mhm.
pool, something like that to predict. Um, and we want, you know, um, we have to know some of the data to predict what's unknown, right? Okay, going back to linear regression. So let's skip this. But yeah, there's a nice explanation here. We're basically trying to find a function um, of this type, y equals mx plus b, where m is the slope, which is basically the angle, right? So if you think of the angle of this segment here, uh, the more you multiply your x, the higher the angle will be, right?
Mhm.
And the
Mhm.
b here will be the y-intercept. So basically, when I was playing here with these numbers, um, so the angle here would be 3, right? So it's the number that I multiplied x. So 2 times x, 2 times 3, 3 times 3, 5 times 3. It's basically the angle, because if I
Mm.
increase this number here, instead of 3, let's say it's 5, the
Right.
the angle will be much higher, right?
Mhm.
Okay, so linear regression is the process of trying to find this function, right? Now I want to introduce a special concept, right? Because we need to know how good the result will be, right? And we can, generate any result, right? There are two options, and you can put any numbers here in the M and the B positions. But depending on what you put there, it will be close to what we want, or it will be far of what we want. And this closeness we call error, right? So think of the error as a distance, and it's actually a distance
Mm.
from what our function is predicting and the real data, right?
Mm.
For
Mhm.
example, so here we have some points with the real data. That's going to be used for our algorithm, our linear regression, to learn about the pattern. Um, And the process of learning, and we can go over this later, is adapting the weights or the slope, which is the angle, and the intercept, so that um, we don't make, or the function doesn't make a lot of mistakes. So we want to decrease this accumulated sum of mistakes, right? And there's actually a name for that. um, we can use a few metrics. For example, uh, the mean squared error, or the mean absolute error. um, Let me explain how that works. So first of all, you know, we can play, and here in the website you can move up and down, and you will see these numbers changing, and the slope and the intercept changing. Okay. For each point, we have the distance of the what it was predicted, right? And the real point. So remember that we are trying to predict the y values, right? So the function is the y here, and the y is basically using the x multiplied by the angle, the slope,
Hmm.
and adding the intercept, adding a little more to that value. So the intercept is exactly where the function will cut the y axis when x is 0, right?
Right.
So in this case, we have around 5. Um, so if you go 0 here, it's around 5. Does that make sense?
Yeah, it makes sense.
Okay, so we want um, to predict y, and we don't want to make uh, you know a lot of mistakes. So let's sum. Well, first of all, this has a real y value and
Mhm.
has a predicted y value, right? The y value that was predicted will be in this line here. Okay,
Mhm.
the distances between the real point and the line, that's what we call error, right? So we sum this error with this error, with this error,
Mm.
with this error. And looking at the points, we can see that it's never going to be a straight line, because the points are kind of changing, but it's pretty close to a straight line, right?
Yeah, right.
In this case, we can just, I think the slope is good, but we need to decrease
Mm. Yeah,
um,
right.
where the line will intercept the y-axis, right? And can you see that, both the mean squared error, which is basically each error,
Mhm.
uh, we take the square, and then we take the mean of everything. This is the absolute value, right? So basically, it's just summing the distances with the absolute value, right? But both are decreasing as we decrease the intercept. So we start with around 25.5 here, around 5 here. If we start decreasing, these
Mm.
errors will decrease, right? Until the point where it gets pretty close to 0.
That's
But,
amazing.
you know, there is another point where it will start increasing again, because, um, you know, it came from above, it decreased, but if you keep going, the errors will increase again, right?
Mhm.
Okay, so we have to find kind of the perfect point. Maybe we adjust the angle a little bit. There you go. I think I'm fine with
Beautiful. Yeah.
0.6. You see now that some points are even like above the line, pretty close, right?
Right. Yeah.
So
Very close. It's kind of like in the center-ish of all of these. Yeah.
yeah, yeah. In some cases, some will be like more distant, some will be closer, but whenever we get a new point, I'm sure it will be close to this line here, right? Um, okay, so we understood what the data is, what a machine learning algorithm is, right? How does it train, right? So the process of training, and I'm not gonna go into specific details here, but we have to think that um, we can't um, just give the algorithm all the data because otherwise, how are we gonna measure if the predictions are good?
Mm.
So there is something called training and testing, right? So we have to split the data. In this case, for example, let's say we take these samples out, um, and they will be used just for testing, right? These samples will train the algorithm, and these samples will test the algorithm, right? Um, this way, we will find if the algorithm is doing well or if it's not doing well, right? Um, okay.
And a question maybe for the audience, right?
Uh-huh.
How come you separate the two and you don't include, let's say, the bottom sample in the top sample as well? Or do you include all of it, but then split it for the testing?
You mean like why or what criteria?
Oh, I suppose I mean in terms of, so you split the data set into a training and a for testing.
Mm-hmm.
And we noticed that you didn't put the testing also in the training, or did you as well?
Makes sense, makes sense. Okay. So these subsets have to be completely separate because otherwise, if the training step sees what will be used for testing, this is a problem that we call data leakage, right?
Mm.
So basically, we are trying to predict things that the model has already seen, right? Um, of course, if the model has already seen it, it learned from it, right? So the probability that the predictions will be good is higher, So we have to hide everything, and we separate completely like training and testing.
Got it. Thank you. Very
Yeah,
helpful.
yeah. It's usually a mistake we can make. Um, and some people do that in interviews, for example, when or real life, when they're splitting training and testing. It's usually recommended that you do that split by time, for example. So you can use, for example, the previous year as training data
Mm.
and the following month as a testing data, you know,
Right. Yeah, that makes sense.
because yeah, if you mix everything, you'll be predicting things. The algorithm will be predicting things that uh, it's already known. So it will be easier. And sometimes we think, oh, my algorithm is doing pretty well. Um, but it's not. It's just data leakage.
Right. And in a lot of cases, that's reducing the error rate because it's training on that training data. So, or the testing data. So yeah, makes total
Exactly.
sense.
Exactly.
Thank you.
Yeah, sure. Okay, so basically, what we saw was um, how to find F, which is what we call the machine learning algorithm or the machine learning model, right? So the model will be this set of mathematical steps that will try to find the pattern in data. Um, we'll save kind of a formula which for linear regression is something as simple as this. Um, and whenever we find a new x, whenever we get a new x, we'll just apply the formula, and this will return a prediction, which will be the y. Okay. But there are several other types of algorithms. Um, and I think maybe we can go ahead and start talking a little bit about classification, which is a different type of algorithm in machine learning. Um, So one thing is to predict a number, a specific number.
Mhm.
Another thing is to predict um, a class or a label, right? So predicting a number is, for example, okay, given the weight of a person, I can predict the height. Or given the zip code, the number of rooms, the number of bathrooms of a house, I can predict the price, right? This is regression. Um, when we want to predict a specific, for example, binary variable, or sometimes it could be multiple classes. We call that classification. It's not um, a number in a range. It's a class, it's a label. For example, a dog or a cat, or the user will click the ad, yes or no. A customer will pay the loan, yes or no. This is a classification problem, right? um, Another way to do classification is to adapt the linear regression and you know add a formula at the end that will basically take that number and split into two different numbers,
Mhm.
using a specific function. um, Another way to do that is called k nearest neighbors, which is another algorithm, or maybe using a neural network, which is a little more complex, but it's a very nice algorithm. Before we go to the classification algorithms, I'd like to take a look at the iris data set, right? Um, so to do that, I think I'll have to present another screen, and I'm gonna switch real quick here. Um,
Yes, this has been a fantastic learning so far.
Cool.
introduction to machine learning. I mean, I'm learning a ton myself. It's always great to go over this again and to learn again from a beginner's perspective. So we'll go
Nice.
ahead and add to the stage your screen.
Cool, cool. Okay, nice. Okay, so I have a Jupyter notebook here, and we can go over, how to create a Jupyter notebook, maybe in the next session. But for now, I just wanted you to look at uh, these images. So the Iris dataset is a famous dataset in machine learning,
Mhm.
uh, because it's a very straightforward way to um, classify different types of flowers, right? And it's a data set that only has um, four features, right? The features are sepal length in centimeters, sepal width in centimeters, the petal length, and the petal width. Everything in centimeters, right? And based on how you measure the sepal, uh, it's a kind of a botanic class.
Mhm.
I had myself to go back and look at what exactly is sepal, because we usually know what's a petal, right? But in some cases, in a lot of cases, the sepal is something green,
Mhm.
uh, but for some reason in the iris flower, it could be the same color as the petal, right?
Mm.
But we think of something that kind of protects the flower, right? That's the sepal. So what they did was they measured several flowers of three types: the iris versicolor, the iris setosa, and the iris virginica, right?
Mhm.
And based on these measurements, um, we you know what, I think I'll just share my um, whole screen. Let me see. I think that would be better. Okay, so yeah, so here is the image of the iris dataset, and let me go back here.
But if you can click hide for the streamer to sharing your screen. Perfect.
Hmm.
Mhm.
There you go. Okay, okay. So here we have the data set, right? So it was first sorted by species, but I
Mhm.
wanted to take a look at how the different features will help us, identify the specific species, right? Okay, so in that case, we need to sort the features one by one, right?
Mhm.
So I have the three types here. So it's 50 um, um, examples of each type. Um, so Virginica, versicolor, and Setosa.
Mm. Mhm.
Um, and we're just going to sort these values. What I want to do, Grant, is to see if there is a way to separate the different species based on these numbers, right? So what happens if we sort by sepal length, right?
Mhm.
Is this a good? Oh man, it seems pretty good, right?
Pretty good. Yeah, it's good. 100% so far.
So
Some anomalies, but you know.
yeah, see, like it's increasing from 4.3
Hmm.
going all the way to 7.9. But
Right.
what you can see here in this pattern is the Virginica. Let me do something. I'm gonna freeze the top one.
Yeah, the sepal length. Yeah, the smaller, right, seems to be the iris setonica.
Yeah, right. The
The
Setosa.
setosa. Right.
Um, and if you go up, you can see, some different this, you know, what would be the
Some anomalies, but for the
yes,
most part.
but we have the versicolor kind of in the middle,
Hmm.
and then at the end we have pretty much the Virginica, right? Um, what if we do with the sepal width? Let's sort here. So the
Hmm.
small ones, so all the way from 2 to 4.4, but it looks like the uh, in the beginning we see the versicolor more, and then we start seeing the Virginica, and towards the end more of the Setosa,
Hmm.
right? If we do with petal length, so wow, so
Oh, that's a good
from
one.
1 to 6.9, but yeah, it looks pretty, you know. See, Setosa, Setosa. Wow, it's almost
Oh,
perfect.
yeah, almost perfect right
Wow.
there. Whoa.
So just one different one here, but pretty much,
That is clean. That is clean.
yeah, that's pretty good. It seems to be the best one so far. Let's see the pedal width. What's gonna happen? I think it's good too. Wow.
Whoa.
Wow,
That is
man.
that is cool. It makes you really just love data, right?
Yeah.
That's amazing.
Yeah, it's pretty similar. So now, if you were an algorithm, Grant,
Hmm.
what would you do to split the data using only let's use the petal length. Um, what would you say? Okay, I know I'm gonna make some mistakes, but what we can say, for example, is like if we take like a cutoff, a
Cutoff point.
threshold
Hmm.
of 2, for
Hmm.
example, or maybe we can even go towards the middle and do like 2.5, or you know we can
Yeah.
say like, okay, so 2.5 is the threshold, so below 2.5 it will be iris setosa, and above 2.5 it will be iris versicolor,
Sounds right to me. Sounds good to
right?
me. Hmm.
Maybe there will be a mistake here, well, Virginica, but we can, and this is what makes machine learning fantastic, because we're gonna learn some metrics,
Hmm.
um, and let me go here real quick. So this is a classification problem, right? So for classification, we have a different way to measure if the algorithm or the model is doing well or not.
Hmm.
And we need to take a look at a few metrics. Um, let me see. Yeah, classification metrics. Something called confusion matrix, right?
Mm.
Um, okay, so when we compare two data sets, um, let me go back here. Let's compare just the Iris Setosa. Well, let's look at the versicolor and the Virginica because there are errors here, right? Okay, so I can say above 2.5 here, uh, everything will be iris versus color. And we can set a threshold to say from here above, everything will be classified as Virginica, right?
Hmm.
We could put like 5 maybe, or 4.9. Let's say we
Yeah.
do 5. So if
Yeah.
we do 5, we make one, two, two mistakes
Hmm.
in this side, but we are also classifying as Virginica what should be versicolor. So this will be an error, this will be an error,
Hmm.
this will be an error, this will be an error, and this will be an error. This will be another error, right?
Roughly
Okay,
6. Right.
yeah. How do we measure these errors? There is something called true. Well, first of all, let's define what's positive and what's negative, right? Um, so we can, for example, decide, we can choose one specific label, let's say versicolor, that will be my positive class, right? I'm trying to predict what's versicolor or not. But in this case,
Hmm.
I don't care. In this example, I don't care about the setosa. I'm just comparing the virginica and the versicolor, right? So everything that's positive uh, will be versicolor, and everything uh, negative will be the virginica, right? But when I create a threshold, some things will be classified as positive when they should be classified as negative, and vice versa, right? So there are actually four types of things here. There are the true positive. True positive is everything that's classified as versicolor, but it is indeed versicolor, right? That's the true positive. The
Right. Makes sense. Hmm.
the true negative
Hmm.
is everything that's classified as virginica, and it is virginica, right?
Right.
So only looking at the data here, what okay, so let's define the false positive and the false negative. So the false negative or the false positive is, for example, something that is classified as positive, or it's in the middle of the positive, but it's in fact negative, right?
Right.
So that's a
Right.
false positive,
Hmm.
right? Um, on the other hand, the false negative is, for example, something like this one and this one. This is a false negative because it's in the middle of the negative, but it's in fact positive. Does that make sense?
Yeah, makes total sense. Makes total sense because you
Yeah,
have these thresholds and data is gonna come through that's not correct, and so we have to find a way to label that correctly.
exactly, exactly. So let's maybe do this. We can even do manually. I think we can create a formula as well, but let's create a threshold as 4.9, right? Everything
Hmm.
here I'm gonna classify as true positive, right? So
Right.
from here, I know I'm making a mistake, but it's just an example, right? True positive. From here going down, it's a true negative, right?
Hmm.
True negative. Boom. Okay. Now let's Let me remove this, remove this. So where is the threshold again? So here. Okay. True positive. Let's start fixing this. So this is actually a false positive, right?
Right.
It's a negative in the middle of the positive, right?
Hmm.
This is also a false positive. This is also a false positive. Um, what
And
else?
same for the 4.9s, right?
Yeah, these
Hmm.
ones are false positive. This is true negative. Okay, what is this? It's a positive in the middle of the negative. Then it's a false negative, right?
Yes,
This
that's
is a
right.
false negative. This is a false negative. Um, okay, that's it. Now, let's try, yeah, let's try to do something here. We can do a way to, count a true positive um, above. So let's add the formulas here. But instead of, um, so it's starting from 52. I'm gonna copy the whole thing. But here it will be true. So Tn will be true negative 44. False positive.
Mm.
Let me see. False positive 6. False negative. We do this. False negative 2. Pretty good. Okay.
Great.
So what we just did here, Grant,
Hmm.
is called a confusion matrix. So what we want our algorithm to do is to maximize the true positive and the true negative. Well,
Hmm.
what's everything that's true and minimize everything that's false.
Hmm.
Um, right? Based on these numbers, we can calculate so many metrics, right? There is something called precision. There is something called recall. So precision is out of everything that should be that is classified as positive. Which ones are real positive, are true positive, right? And recall is, for example, out of everything existing that should be classified as positive, how many your algorithm captured as being true positive, right?
Wow, that's amazing. So now we're able to figure out really specific classification on large data sets.
Exactly. Yeah. So you know what? Let's see if we can reproduce here. So true positive 48, true positive 48, um, true negative 44, true negative 44. Here you go. False positive 6, false positive 6, and false negative only 2. False negative only 2. So this is the matrix. So actual positive and actual negative versus
Hmm.
predicted positive and predicted negative, right?
Hmm.
So these things will be either true positive, false negative, and true negative.
Mm.
Um, there is more information here about the formulas if you want to calculate precision, recall, specificity, for example, and you can see more information here. But here, there are some numbers. Our precision would be 88.9, right? So in
Right.
this case is the number of true positive divided by everything that was calculated as positive, which is
Mm.
true positive plus false positive. So all of all positive predictions, how many were correct, right? And the recall, on the other hand, in which in our case was 96%, pretty good, is of um, all actual positives, how many did we catch? So the number of true positives um, divided by the sum of true positive plus false negative, which is, a false negative, it's actually something that should be predicted as positive, right?
Right.
There are other metrics that I'm not going over today. I think there will be a lot. But I think for now, I think this is a great introduction. We do have a whole notebook to present, which is the set of analysis. But I think it will be better if we leave this for the next time. For example, how to analyze the data, how to make some plots to understand and to visualize what we saw just by sorting the different columns in the table. But I think this will be too much for now.
I think
Um,
I'm super excited for the next session already to visualize the data, play with the data even more. And as you mentioned, I think everyone learned a lot from this video. I think you broke it down in such a way that it simplified and made clear what a lot of these, for lack of a better word, features are in machine learning. And
yeah.
I think it's very, very useful for the audience. So thank you so much, Leandro. And and you've been working in machine learning now for many years now, is that right? How many years
Yes.
have
Yes.
would you say you've been like working with it? You're also studied as a PhD, is that correct?
Yeah. Oh man. Yeah, probably more than 10 years. Yeah, because I finished my PhD 10 years ago. So after that, I did a postdoc. I spent some time at Gladstone, like I think five 5 years more or less, and then 2 years at Meta, and now 6 months at Block, my current full-time job. Yeah, a lot of
Wow.
time. And
Yeah, and that's what's great is that, with your experience, you're able to break things down because, a lot of people maybe you have to have like a lot of knowledge to be able to break things down in such a way that you make it easy for beginners. So I want to thank you on behalf of our community and people around the world that will watch this video and learn a lot more about machine learning. So we're going to go ahead and post this video soon, and everyone's going to absolutely love it. Let's go ahead and yeah. So, any closing thoughts on machine learning and what we'll be learning about next?
yeah, I think it's a process. These days, it's become so easy to create code to analyze data, but not only um, by creating the code, but more like understanding what the data is, how the data looks like. That's the most important part. Um, and machine learning is huge. It all starts with a simple analysis in a notebook, and then you start like deploying models, testing models in production, and there are like whole systems that we call like machine MLOps, machine learning
Right.
operations, to make sure the data is coming from the right place and being transformed the right way, and the predictions are being executed like at the right time with low latency. um, Man, it's huge, but it all starts by you understanding the data, understanding what the model is doing, what the metrics are. But and it takes time. It takes a lot of mistakes. I've made a lot of mistakes in my career, but this way we keep learning. You have to. It's a process. It's not in a few days that you learn something like this, but there's always a start. And you know the world needs more and more people with a machine learning and AI background. So that's a huge opportunity.
Absolutely. So it sounds like your advice would be to learn the concepts of machine learning, understand the underlying data. What advice would you give someone that's new to machine learning and would like to move forward?
Yeah, so start creating your own projects. If you are in a research institution, if you are already working with data, try to add machine learning to your daily work. Maybe talk to your manager, propose something, start playing with the data. Um, don't, people sometimes come to the area because, it's a well paid position. But, sometimes if you spend time just learning, that's priceless. Because um, even if you are in a position where in which you don't have the salary you want, but if you are learning, man, that's a huge opportunity. um, and it takes time, it takes patience. um, you know you just have to keep going. It's a process.
It's a process. We keep going at it. We keep learning, and before you know it, we know machine learning, and great things are happening. I mean, I know
Yeah,
that with DeepStation, we started a few years ago, and started with sometimes it's like 10 people, and now we're a community of over 3,000 folks. You just keep going. You keep
amazing,
learning. You keep growing.
amazing.
And thank you so much for sharing your insights. One last question before we go. What do you love about machine learning? What do you love about, and what made you want to kind of learn more about it and to build with it?
Yeah, what I love about it, it's that kind of seems like it looks like magic sometimes. Where it's actually just, um, algorithms trying to find patterns in the data. But it's so nice, man, the way you prepare the data. Um, and for example, you predict what a written number is, or you know if a picture is a picture of a dog or of a cat. Some people are using machine learning to detect um, you know robbery, you know when people are removing things from shelves in stores. um, and man, it's amazing, so many applications. I'm helping a company recently that's using AI to detect emotions in kids' conversations. So the possibilities, are infinite. Basically, it's fantastic.
That's absolutely beautiful, and I think that's a great way to move forward and for to capture the imagination for so many people. That is like magic. You're able to do so much with it. It can transform lives, and I can't wait, Leandro, to learn more from you, and for our audience to learn more from you as well in the next episode in the series. So thank you
Awesome.
again, Leandro, and I look forward to seeing you again soon.
Of course. Yeah. See you soon.
Amazing. Take care and have a great one, everyone. Bye bye.
Bye.